Okay, the first 5 terms of a sequence are shown here. And they want you to write an explicit function to model the value of the nth term in the sequence such that f of 1 equals 4. Okay, the notation makes this seem more confusing maybe than it needs to be. What they're saying is that when n equals 1, okay, if f of n equals 4, in other words, when n equals 1, the first term is 4. And you can see that in the sequence here, that the first term is 4. And so what we can see happening here is that to find the nth term, we can take the first term and do what? All right, what I see happening here, and what you hopefully also see, is that to go from one term to the next in this sequence, we just keep timesing by 3. So this is exponential growth here. We're tripling. So if we're tripling, we want to just take the first term and times it by 3. And how many times do we multiply it by 3 to find the nth term? We multiply it by 3 n minus 1 times. Okay? N minus 1 times. So in this case here, the nth term, that would be f of n, would equal the first term, that's 4, multiplied by 3 raised to the n minus 1 power. Okay, and so let's check this model. I can see in the sequence 1, 2, 3, 4, 5. The fifth term is 324. So let's make sure that our formula here works. Okay, if we check this, does this formula tell us that the fifth term is 324? Well, the fifth term can be found, f of 5 in other words, can be found by taking 4 and multiplying it by 3, 5 minus 1, or 4 times. So this gives me 4 times 3 to the 4th power, and you can grab a calculator if you want, and you'll see that sure enough, f of 5 equals 324. So this formula worked to find the fifth term. You could test it to find the fourth term. You could make a list, but this should be enough for us to confirm that. That expression, 4 times 3 to the n minus 1 power, that would model the nth term in this particular sequence. So 4, and then in parentheses 3, and then you may have to use like a little caret. So get onto the website and practice using the notation or the technology. So that would work there, or you could say 4 and then just times 3 raised to the exponent n minus 1. So those expressions should work there. Let's look at 24. It says a landscaper puts 5 fish into a pond. That's where we're starting at. And the number of fish doubles each month, times 2 each month over a period of time. Write a function to model the number of fish in the pond after X month. This is a doubling problem here. So you can always find the total by taking the starting amount and multiplying it by 2 if you want to double. And how many times do we want to double? Well, each month for X number of months. So in this case, the total is being represented by this function notation, f of x. That's the y in the equation. Okay, that's the total. And we can find the total by taking the starting amount, which is 5, and multiplying it by 2, x number of times. All right, that's what the equation would be to model that exponential change. Take your 5 fish and times it by 2 each month. So, you know, we can see this. If we make this sequence, for example, we start with 5, and then if it doubles, there's 10, and that doubles, and it doubles, and it doubles, and it doubles. Okay, I can see that let's see. Started with 5. So after 1 month, 2, 3, 4, 5. Okay, so at times 0, at month 0, the number of fish should be 5. That's what we started at. But then this is 6 months later. So let's test this. I just listed out my sequence. Let's see if this equation actually results in the 6th month having a total of 320 fish. Well, let's see. F of 6 can be found by taking 5 and multiplying it by 2 to the 6th power. Multiplying it by 2 6 times. So let's check this out, because 320 fish after 6 months. So 5 times 2 to the 6th is 320. Sure enough. So I can, again, if you want to check, make sure that your formula checks out. That's what we have to do. I'd say the trickiest part of that is determining that the starting value, 5, had to correspond with 0 for the X number of months. It was 0 months at the start. So the value of 5, that starting value, corresponded with month 0.